I am excited to show you the Toyota GR Cup Racing Analytics Dashboard. This is a data-driven solution that we have built which transforms the raw telemetry into actionable insights for race teams. So this dashboard analyzes over 23 million rows of racing data to answer two important questions. One is, when is a driver getting fatigued? Two, when should we replace car components or the individual car parts? Let's go in. So this is the dashboard. Currently, if you see, I am hosting it locally on my VS Code. So I use this script run dashboard.sh. This is the project space that I have, and this is the overview dashboard. In this overview dashboard, we have total number of drivers, how many laps have been completed, what is the fastest lap, and how many races have been noted down, right? And if you see here, this is the result summary. At the bottom we have the weather chart which shows temperature tracking and humidity throughout the race. This critically impacts or these are critical factors that affect the performance and driver comfort. Next, let's go to driver performance and fatigue. So this is a dashboard. If you see here, we have selected the driver number, that is driver number 2. We have selected the race, which is race 1. And if you see here, he is fatigued. That means he is tired, a low fatigue. Now this can happen due to multiple reasons, right? There may be lap time degradation over the race, there may be consistency decline, total driving duration, and sector by sector variability. So these are multiple factors that involve that are needed to calculate the fatigue score. So if you see here, this chart shows lap times throughout the race. Notice how the lap time increases towards the end, right? That's the fatigue that is setting into the user. This trending line makes this degradation crystal clear, right? So here is the sector wise breakdown, sector 1, 2 and 3, right? Sector 1, 2 and 3. If you look at this chart, sector 1, 2 and 3, we can see exactly where this driver is losing time. Sector 2 shows the most variability, suggesting inconsistencies in the middle section of the track. And this rolling average chart shows how consistency degrades over time. The standard deviation increases as the driver gets tired. Next, let's look at card parts fatigue. This is where, give it a moment, it is still loading. So if you look at, this is the car parts fatigue analysis, right? So this is where the engineers who have built the car can make good decisions or better decisions, I would say. Starting with the brake system, we are tracking every brake application and the cumulative pressure applied. This driver made over 2000 brakes brake application with a fatigue score of you know with a fatigue score. So they have to be inspected. Similarly, the engine analysis. So this shows the RPM distribution. This histogram reveals how much time the engine spent at high RPM. Critical for predicting how much wear has happened to the engine. Right. Next, we have the GG diagram. This shows the performance envelope of the car. Each point represents lateral and longitudinal g-forces. The outer boundary shows the maximum grip being used. This reveals driving style and tire stress patterns. Now on to the last part, the comparative analysis. Let's look at each of these comparative analysis, right? So here the bar chart shows fatigue scores across all drivers. We can instantly identify who needs rest, anyone in the red zone above 70. The detailed table shows lap times, consistency metrics, and total laps. This helps team managers or the racing team to make better decisions and help that team win the race. So this dashboard is specifically designed to analyze the Toyota GR Racing or Ginzu Racing analysis. We have built this using Python, Streamlit, and Plotly, which handles millions of data points. This also provides real-time driver fatigue, physics-based component wear analysis, and the interaction with the dashboards or the charts uh, is it has been designed such a way that people can change and look at what is the score, what is the fatigue score, what is the um, can zoom into the dashboard, and various other features have been built into it. Thank you. Just last point before we close, we have uploaded uploaded the the entire project into GitHub, which we would share with you all. Thank you. The only way to run this using or the to run this application is to best run it locally. We were not able to push the telemetry data since this is pretty huge. GitHub allows only 100 MB of data to be pushed to its repository. This the data size of telemetry data for race 1 and race 2 is around 1.6 GB each, so we were not able to push it. Apart from that, we were able to push all the CSVs that we have used, all the analysis, some references. The documentation has been integrated into this dashboard, into the repo. Few troubleshooting guides, and we have implemented rainflow counting algorithm to calculate fatigue. We have used different algorithm as well. We have documented all those stuffs. Thank you very much.